Our esteemed speaker this evening has over 25 years of industry experience, during which he has overseen the deployment of Postgres at major Fortune 100 financial institutions and military facilities worldwide. Please welcome the General Manager of Second Quadrant North America, Tom Kincaid.
All right, thanks very much, everybody. As Eric told, I'm very delighted to be here. I came all the way from Boston, and we have, Umair is also with me. Umair, where are you? Way in the back there. He'll be with me too. He's come all the way from parts on the other side over from Pakistan for this event. So we're taking a lot of international element to it. Okay, I am Tom Kincaid. I'm the General Manager of Second Quadrant. Second Quadrant is a company that's very focused on Postgres, and I'll tell you a little bit about us. I'll tell you a little bit about me. And then I'm going to talk a little bit about Postgres 11. And I'll talk a little bit about futures of Postgres. And I'm getting into a few war stories as we go, things I've done with Postgres that have worked well, things that haven't worked so well. And we'll have a lot of fun for the next 35 to 40 minutes, okay? So please, I'll take questions at various points. I will ask some questions too, and we'll go from there, okay? So Second Quadrant is a company that is very into developing Postgres. We've contributed features. It was founded by a man named Simon Riggs. Happens to be my boss, a former speaker here at Database Month. I came to my first Database Month was seeing Simon speak. And anyhow, Simon was told when he was enterprise architect to find an alternate solution for Oracle. And as he was walking out the door, they whispered in his ear, Microsoft. And as he was getting to the door, he decided, you know what, I need to really sit down and figure this out. Simon being Simon, spent a lot of time looking at a lot of databases, and then what he came up with was Postgres. Postgres was the right solution for what his company needed to do. And he saw some things that were missing in Postgres. And the first thing he implemented was backup and restore for Postgres. So they always had a dump, but I'll call it physical backup and restore for Postgres. And over time, he formed a company of Postgres developers, people who can contribute to code to Postgres, advance the technology. And that really became the people who wanted to work with Postgres and advance it and make it better. A company that's funded by doing technical support for Postgres. So it's a really, it's a great thing. You call and in the middle of the night, your database has an issue. You get some guy in New Zealand who wrote part of the query planner to help you through the code. That's your first level call. That's the person you speak to. Or the person who wrote some aspect of backup and restore or vacuum. These are the people you're dealing with or supporting you, committers and authors. And here's some of the features we've had developed over time. So backup and restore, point-in-time recovery, stream and replication, logical replication. Now, we didn't do all these ourselves, but we led a lot of these and participated in them. And I'm talking about some of the ones we did in the current release of Postgres. And what we've done in Postgres 11, we contributed in Postgres 11, is stored procedures with transactional control. So not only have we written much of the code, we've also written many of the books around Postgres. So we do Postgres and nothing else. Okay, so as Eric mentioned, I am Tom Kincaid. I've been with Second Quadrant for about 2.5 years. I run the U.S. operation, support, sales, consulting, and I work with a lot of businesses here in New York who are deploying Postgres. And I think I've worked with some of you over the last couple of years. I've been building and deploying database technology for about 25 years. I'm an original veteran of the object database industry. Has anybody here worked with object databases way in the past, in the 90s? Yeah, okay, so one person, me and you. Okay, so that's how things come and go, but that's a very real testament. Things like object databases, network databases, NoSQL, they've had their time, and some have had some level of stickiness, others have not. But the relational database, the core relational database, has been around all that time. In fact, it's not only has it been around, it's actually growing. And Postgres, in terms of its adoption, is also growing. So which of the four major cloud vendors, my first question, which of the four major cloud vendors, we'll call them Microsoft, Amazon, Google, IBM, which of them offer Postgres as a service? My first question. All of them, right? As they say, they all offer Postgres as a service. All right, so this is the type of thing, they're all doing this and they're all growing. And in many cases, and several of those cases I happen to know, it's the fastest growing service they offer. So Postgres is gaining lots of adoption, and I'm going to talk a little bit about why as we go through this. All right. By the way, I guess one other point, I'm the founder and the organizer of the Boston Postgres User Group. So if you ever get to Boston, after you park your car, come visit us at the Boston Postgres User Group. What's that?
Any group in New York?
I'm not associated with the New York group. I am a member, but I haven't. I'm not. Yeah. So.
Sorry to interrupt. What year the Postgres was?
When was Postgres built? That's a really good question. So I'll give you. I'll diverge a little bit. There's a little bit of a history here. There was Postgres came out. I think it was in. There was a group formed at Berkeley that was doing some development, led by Michael Stonebreaker, and I'm going to say that was the late '80s, that type of thing. And then there was, I don't forgot what it was initially called, but well, it was actually I do know it was initially called Postgres because it was post Ingress. He had developed much of Ingress, and he developed Postgres as a project that came after Ingress. At some point, it became open source, and then a group, the Postgres Global Development Group, founded by several key members. One, Bruce Momjian, who works for EDB, who you'll see sometimes here, and then another guy who works for Second Quadrant, named Mark Fournier, founded the Postgres Core Development Project, and it's been taking off ever since. Okay, so what I'm going to talk a bit about is the Postgres development process. It'll give you a little bit of insight as to what goes into a Postgres release. And then I'm going to talk a little bit about what's in the current release, Postgres 11. And then I'll tell you a little bit about some of the major features, some of the things that Second Quadrant contributed, many of the things that were contributed by other companies as well. All right? And then I'll tell you what didn't make it in. And some of our things didn't make it in. And I'll tell you why. So this is roughly what a Postgres release looks like. There's 4 commit fest, followed by a beta stabilization period, and then a final beta, and then a general availability. All right? And what happens is people submit patches, and then a group of committers will give feedback on those patches. And Second Quadrant employs a large number of committers and participate in that. They submit patches, and then as the feedback comes in, eventually it gets good enough through the feedback, through the testing cycle, through the evaluation, through the review process, that it gets committed. And the commit fest runs for a defined period of time, and there's 4 of them. And then when the 4th commit fest completes, then we go into a lengthy beta stabilization period. So here's roughly what the schedule looked like for Postgres 11. All right. So the first commit fest started in 2017. It then went on. Then the next one started in November 2018. I won't read all the slides here for you, but effectively you can see from March really to the end of October, it was feature complete. And it was all about stabilization and testing and finding bugs. And that's one of the key reasons for Postgres adoption is that it works. Okay? The fact that it has lengthy beta periods where there's this continual evaluation. It's feature complete. So you almost look like the feature development or feature committing is almost the same length as the stabilization period. And again, this is what I call one of the critical aspects is that you don't lose data. That people don't view that as a feature anymore, but it really is a feature. All right, transactions commit, and you don't lose data. So this is what I did. I made a graph. Somebody posted all the Postgres features released by the number of features released by release. All right, so 7.4 it had about 300 features, and it peaks out around 350. And oddly enough, Postgres 11 had the least, over 150 features. But I'm going to talk about what that means in just a minute. Okay, but that's really quite something when you think about it. 150 features over the course of 12 months. What other technology does that? What other database technology does that? And releases very stable, very useful features. So the question begs itself, are we getting fewer features? So I'll give a question. So the answer is, yeah, we're getting fewer features, but are we getting fewer functionality? So the answer is no. Really, what was happening in the early days was the easy stuff. And I wouldn't say nothing's really easy in the database world because it has to be so correct and so wonderful and all that. But I'll say the simpler stuff has kind of led up to this. I would call the last several releases breaking new ground, breaking new barriers for Postgres. And when I was about 5 years ago, I was asked to speak at the Postgres European Conference. And it was called, the title of my talk was Postgres, the Next 5 Years. And Eric spoke briefly about what state has the most core team members. Anybody know what a Postgres core team member is? Okay. So Postgres is governed by a group of core team members. There are 6 in the world. And they're usually people who have been around Postgres for a lengthy period of time. And they've been contributing features to Postgres. Or they've been doing evangelism around Postgres, or they've really made strong contributions to the community. It's really part of their life and has been for a long time. And they govern the project. So if there's issues or conflict, they govern it. And what I did is during this development of this presentation is I interviewed all of the core team members. I said, so what has to happen to Postgres in the next 5 years? And again, that was 5 years ago. And I kind of came away with this concept about Postgres. It sort of had what I would call middle out growth. If you think of databases 5 years ago that were easy to use and developer friendly, they'd be down at this end of the spectrum. And if you look at things that are, you're going to build your business can't run without it on, okay? Recording people's money, transactions, sort of thing. That's at that end of the spectrum, all right? And over time, Postgres initially started out, it wasn't at one end or the other. It was sort of in the middle. Okay, you know, it didn't have things like that. So, thoughts on why this was why it wasn't really strong down here? Did anybody have any ideas? I have my. This is an opinion thing. There's not a right or wrong answer. But how many people have been using Postgres for any, the last? Have used Postgres at all? Okay, so okay, so. What I will say is this really, I think in the early days, why Postgres, MySQL really took the world by storm as the key open source database back, I guess you could say maybe 10 years, going back 10 years now. So why not Postgres? Well, my feeling is there's 2 things. One is Postgres didn't have a one-click installer. So that first 15 minutes you have with the database is very important. And it also didn't have a Windows port. At the time, Windows NT, Windows 95 were very important. So it didn't really have those. It didn't have a really stable one. It was the Linux database, and you didn't install it. You downloaded the source code and you built it. And so while if you were a database developer, that's very friendly and cool. But if you're a general application developer, which by and large across the tech industry, that's the biggest demographic, it didn't appeal well. And again, while I said it had transaction consistency and ACID properties and had wonderful SQL compliance, it didn't have some of the high-end features you might see in something like Oracle. So this is what I think has happened over the last 5 years, is it's had sort of this middle-out growth, okay? So it's stretched more so towards the ease-of-use, developer-friendly world, and more towards you can run your own business on it. And I think really in Postgres 11, it's contributed a lot in this world. Things like a parallel query, things about data partitioning. This is really what I think Postgres 11 has been about. So this is some other statistics about it. So this is, over 1 million lines of code. Now, obviously, that's not all in core, but that's in the surrounding features. 220 commits, all right? 313 different people contributed to Postgres 11, or made some sort of contribution to it. So when you think about a large database team, that's pretty good. There aren't too many database teams that have 300 people working on it over a period of time. So it's a very healthy statistic for Postgres. So here are the things I would say. One thing people will say if I talk to the core team, they'll say the features that were introduced in Postgres 11 were probably some of the most difficult yet over the past 10 years or so. And we'll talk about what some of those are. But to give you the highlights, one is stored procedures. Postgres has had functions for a long time, but the actual thing with procedures, the ANSI standard around procedures is new in Postgres 11. And I'll talk a bit about what that means to be a procedure versus a function. Just-in-time compilation, and many new functions around partitioning. All right. So let's talk a bit about stored procedures. The big value with stored procedures is you can do commits and rollbacks within the server-side call. You can't do that we couldn't do that prior to Postgres 11. Now, when you think about coming from a world, a lot of people are wanting to migrate from a proprietary solution that uses this concept where you could have commits and rollbacks on the server side or in a loop. Every 1,000 iterations, I'll commit the transaction so I don't lose an entire bulk load operation. But this is enabled, because of that, now there's a lot more applications we anticipate will come over to Postgres just because they can't be migrated without these semantics. And there's real need for it. So that's something that folks are very excited about, and we're already seeing that. A lot of people are coming from other databases and introducing their application to Postgres. This is the thing that kicked the door open for them. So again, more applications running there. Okay, but just to kind of call out this thing is I have something here. I insert hello. I commit. I insert world, and I roll back. And when I call out, only hello is in there. Okay. So here's another one with a batch update where I get to every 1,000 rows I do a commit, so I don't lose the entire transaction. But these are things that are just very simple things, things that just make it easier to get onto Postgres. So I'd say that's a headline feature of Postgres. So who here, so I say I've been around 25 years. The truth of the matter is I've been around this industry over 30 years now. I'm old, sorry, okay. And one of the things I did when was this? I guess it was in the mid-90s. I got called by a friend of mine who was working at a company called Sun Microsystems. Anybody here familiar with Sun Micro? How many people have heard of Sun Microsystems? True story. Okay, I'll ask another question. How many people here have heard of Digital Equipment Corporation? Oh, bless you. I was in in Hyderabad about 2 years ago, and a group of young kids, all under 30 years old, maybe 20 of them. How many of you here have heard of Digital Equipment Corporation? One person raised their hand because they had seen it on somebody else's LinkedIn. I mean, this is 100,000 people work for this company. Nobody's heard of it. Anyhow. So anyhow, while I was at Sun Microsystems, I was hired by a group of developers to work on a project called Oak, which over time became the Java programming language. Initially it was deemed to be too slow for real applications. And the thing that really introduced it and gave it the boost was something called the JIT. So I guess we said JIT. Did anyone want to? I don't have it up here, do I? So I didn't ask you the question that was on the slide. Yes, JIT stands. What is? Oh, I did say. I already said it. Okay, JIT stands just in time compilation. So things that were typically interpreted, read statement, execute statement, read statement, execute statement, then interpreted, instead are compiled and then executed just in time, so to speak. And it made a really big difference in the adoption of Java at that time. And that was really exciting. And so I'm very excited about this particular feature. Now, it's a little bit hampered. This is the first release of the feature. I'm going to talk about how features grow over releases. But yeah, the just-in-time compiler was introduced in Postgres 11. All right. And it's very good if you have long-running CPU-bound queries. All right, so you're doing something that there's a lot of computation in your query, a lot of analytics. So this will But again, this is something that will open up Postgres to a whole new class of use cases. The overhead is about 600 to 800 milliseconds to plan the query. So initially, there are going to be a lot of queries where JIT is not appropriate. The optimizer is a little simple. Now, again, I'm going to talk about how things go from initial feature to something much more involved. But the idea is that the query cost, you evaluate the cost of the query and you compare it to a value. If the cost of the query is greater than the JIT cost, you execute the JIT, all right? And then there's the additional optimizers and there's inlining values. But effectively, those are the tuning parameters for the JIT. All right, so here we have something where we're going to do a query. We're doing explain, analyze, select rel pages. All right, just a very simple query in Postgres. And here's the query plan you get. Okay, and the planning time takes 116 milliseconds. The execution time takes 365 milliseconds. All right. And it returns 4 rows. Okay, now what I do is I lower the JIT cost. Okay, so you see that whenever you're looking at a Postgres query is a little bit of a. You see up here, what it does is it estimates a cost. Okay, and it's comparing that number to the JIT cost. Okay. Since this number, now I've lowered the JIT cost to be lower than that number, when I re-execute the query, you see that I get a different plan that involves the just-in-time compilation. And in this case, things get worse, all right? But it's one of those things you can evaluate how your queries will perform just by tuning this parameter.
Is there any default value?
What's that?
Default value?
By default, the JIT is off. So the first time they didn't want, so they didn't want people to upgrade to Postgres 11 and experience, wildly different behavior on some queries and optimizations on the other. So you have to turn it on. I don't know what the default value is, but I think if you look at PostgreSQL,
It's off then.
yeah, well, there's off. But then if you look in, if you go to PostgreSQL.conf and you look at, you search for that, you will find the default value. Okay. So, go ahead.
Ask real quick.
Sure.
How has the compiler, the desktop compiler, affected performance, like in general testing?
Yeah, well, there's been a number of things where it's, a number of things where it's significantly better, and a number of other things where it's significantly worse. Overall, I'd say it's better from what I've been able to read. I personally haven't done a study analysis, but just reading the Postgres hackers list and contributors, I would say overall it's better, but it's different enough in some cases that it's off by default. So I think what will wind up happening, my prediction is not this release, but the next release, it'll be on by default. And that's very similar to the evolution of the way it was in Java. It was off by default. And then over time, people would enable it and things got better. So I think it's, I think there's lots of interest. It'll win. Another question?
But mechanically, is it sort of a lazy compilation? Is that why you're saving time? In other words, you're compiling as the queries execute rather than doing it all up front?
Right. So it's sort of that just-in-time element to it. So you don't compile it before the at the beginning like you would a program, like you would Postgres, right? The idea is that it reads in the query, it compiles it. So there's the initial overhead. So the subsequent executions are faster. Mm-hmm. Other questions? Okay. So kind of looking at Postgres, I've talked a little bit about how features get incorporated in. They kind of go, initially there's a basic working feature. So Postgres 9.6, basic parallelism showed up, okay, very basic features around. I believe it was just a parallel query on sequential scans. May have been more, I'm not certain. But that showed up in Postgres 9.6. In Postgres 10, you got a lot more of that. You have parallelism showing up in many. So sort of the plumbing and infrastructure for Postgres parallel query execution showed up in 9.6. Postgres 10, you got much more of it. And then what happened in Postgres, also happening in Postgres 10, was you got basic partitioning features. And Postgres has always had partitioning. Well, it's never had what they call declarative partitioning, meaning there's never been syntax for partitioning. You could do it through sort of what they call table inheritance and range values. But in Postgres 10, they introduced declarative partitioning, actual partitioning syntax. The big thing that happened in Postgres 11 relative to partitioning is it got wildly more features and wildly faster. And I'm going to take you through some of that in a minute. So if we take a simple case where we have a table in, it has a sensor log, okay, we'll call this some sort of IoT application. All right. What I would do, it's kind of hard. Okay, this is a little, let's see if I'm going to actually, it doesn't come through too well on the screen here, but what I do is I create a table, sensor log, and then I create a child table, log partition 2014, all right? So all the values, sensor readings in 2014 go into this child table. All right, so I create the sensor log table, I create the child table, and what you can't see down here is inherits. It says inherits from the sensor log. So I'd have an inherited table for each year. Okay, so that's, you can see I've got to do all this, all right? And now what I would do, again, this is a 9.6, is I would have a trigger that would execute on each row on insert. So what it would do is it would look at the value and it would determine what year it was going, and it would insert it into the appropriate child table. And that was partitioning until Postgres 10. Now that's clever and it worked, but there are a couple things. It was slow, and that looks nice, but now all of a sudden I've got to repartition, or I've got to change things in some way. This trigger becomes very difficult. Every time I add a partition, I've got to add a new value to my case statement. I've got to have a new table. Or if I want to split two partitions, I want to split into every 6 months as opposed to every year. You can see this becoming unwieldy, and it's just more code. It's a lot to work with. So Postgres 10, it did a couple things. It created a very simple syntax, okay? So all I did in this case was I said here's the table, my sensor log table, and then I just created partition for 2014. And then I say what the values are, the ranges. This is a range partition. And that's it. All right, so you can see that I've gone from all that code here to here. And it was a fundamentally designed new architecture for greater things to come. All right. So here are all the features that went in for partitioning that went into Postgres 11. This is over the course of 13 months. So you had all this. One is having a default partition, all right, and it's hash partitioning. I'm going to talk more about that in a minute. Okay. Let me go all these. But the idea that if I update a row, it will move to the new partition. All right. So if I partition by year, and year is in column 1, I change the year in column 1, it'll move it to the new partition. Okay. By the way, anybody have any? What are some people? I'm talking a lot about table partitioning, but anybody want to give a summary of some of the best use cases for table partitioning? Because I think it's always valuable to understand where these things come from.
We just implemented partitioning from 10.5, and we loaded around 8.1 billion rows.
8.1 billion rows.
Yeah, and we are very happy with subsequent results.
Yep. That's one thing I will say in Postgres 10, the tuple routing, the loading of tables is much faster than in Postgres 9.6. And so you got a very very good data performance load.
We were using timescale just for comparison,
Yep.
but then we altogether avoided timescale DB and concentrated on
On Postgres partitioning. Good. That's good. Okay. Well, and timescale DB has a lot of value, outside of that. But yes, I understand. Yeah.
I actually have not done anything with partitioning, but I'm going to throw a use case out there.
Sure. See what.
So I've worked in a lot of companies, and the big problem with any kind of data is archiving. So if you're pumping in lots of records with a timestamp over a 15-year period in some cases, then partitioning would be great because you can maybe easily. You partition by date, and then you keep the last 2 years of data online. A new month comes in, you archive the old month and just drop the partition. That's a very classic use case.
Sometimes you partition by region, no?
Yeah, partition by region, yep, by data access. So I'll give you sort of the case where I first got introduced to partitioning, my first story. We had a query, I was sent to a major financial institution in Canada. They had a query that was taking 10 minutes, and it was coming from another database and it was taking significantly less than that. And we spent a long time looking at why is this so bad. It was doing a full table scan when it should have been doing an index. Should have just done an index lookup. And so, what's going on here? Well, what was happening at the time was the query planner said, the index is too big for me to load it into memory. It's 2 gigabytes. I can't load into, I don't have enough, I'm going to use up too much of the memory. And so what we did is we partitioned the table, this 1 terabyte table, into partitions of, I can't remember, maybe it was 100K per partition. And then you create an index on each of the partitions. And now you have a lot of small indexes, and the query could just visit the appropriate partitions. And that was much smaller, much faster, much lighter. And that was the first time I really started to really understand the value of partitioning. And the use case you mentioned is a very common one. It's a very good, probably the best one. Is that I can partition, I partition by a date or some other range, and new partitions come on, I drop old partitions. And so it's a pretty, when you get into large-scale databases, it's very important. This is something that, this is kind of, okay, so this is, I don't have any, I guess, do I have did you give away all my swag? Do I have one more book left? I have no books left. Okay, well, anyhow, just for the sake of winning, partition pruning. Does anybody want to tell me what partition pruning is? This is a very fun topic. Partition pruning. Okay. Oh, yeah.
Maybe going back from partition to just regular raw data.
Partition is going back from
To the actual table. Partition to the
that's very close. But so I'm going to give you the book. All right. Oh, serious? Okay. I'm going to let you hold it for a second, okay? And then I'm going to give it back to the owner, okay? Oh, I have more books. Okay. Oh, I have. All right, we can play a little bit. Okay.
You continue.
I'm going to give you 2 books because I took away one. Okay.
Is it just to clean up? I mean, this could be raw data. You might want to clean that data up in these different parts.
That's an excellent answer, but not the right answer, but still an excellent one. So okay.
It's how database finds out that which partition to touch to find out.
Exactly. Okay. That's you were going to say that, right? Was that the?
I didn't hear what he said.
Okay. Yeah. Okay. What he said was it's how the database determines which partitions to visit, right? Okay. So if I have a query, select all stock symbols. All right. So let's select all stock trades that occurred in the year 2014, and I've partitioned trades by year. Okay, and I have 100 years there. The query planner knows to just go to the 2014 partition. It doesn't have to visit all the other partitions. It only has one small index to load and one table to deal with. All right, and so you can get a lot of optimizations in this way. So they call that pruning. Okay, and so prior to Postgres 11, you always had to have a constant if you were going to get good pruning, all right? You'd actually have to have the value 2014 in the query. Okay, so, and whereas now in Postgres 11, you can actually have a variable in the query. So they call that runtime pruning. All right, and we spent a lot of time. The second quadrant spent a lot of time on that. Yeah, good question.
Does that work across multiple partitions, or does it still have to resolve those?
Yeah, no, it can work across multiple partitions, right? So the idea is, the question is, so if you had 2014, as the query gets more complex, it gives up and it can't prune. You know, but that's this thing is when later and later releases, the pruning gets better and things are great. You know, pretty much if it's it'll work with multiple values in the query.
It's almost like indexing the partitions essentially, right? Because it knows where to go.
Yes, that's right. So it's kind of it's a way of you know, only visiting what you need to visit.
Is there any application for like time series database like analysis doing?
There are you know, people who use this for time series analysis. There's a time series DB, which is an extension of Postgres, which covers a lot of very high-end cases on this. But this is you know, moving in that direction.
Is there an option for a global index?
There is no global index in Postgres, and I don't know why, but people don't seem to. You know, it's an area of great debate. I've heard people who speak out very strongly against them, but there is no global index.
Can you physically tell how to allocate a particular partition on an array of,
On an array. Okay, so the way you would do it, what you
using like language?
I'm sorry, can you?
Postgres, yeah, I'm using Postgres.
I'm sorry, I didn't quite understand. So what is it you want to do?
I mean, if you want to allocate some partitions in some particular storage.
Oh, right. Okay, what you would do is you would create a table space in Postgres that would be mapped to a certain directory, which was on a certain storage device, and then you would allocate the partition in the table space.
And you can then
Yep, and that's a very keen optimization too. That's a very good use case for partitioning. Is you could have each partition on its own drive.
Yeah, or something.
But you know, in the modern storage world of SAN arrays and things like that, it's harder to achieve that. Okay. So this is another thing that came out in Postgres 11, something called hash partitioning. All right. So the idea is now this is a very good. Another good question, and I had to spend a little time thinking about this one. So hash partitioning, where I have a value, and based on the value, it goes to a given partition, you know, either by modulus and remainder. Anybody think of a good use case for this? What is the best use case for hash partitioning?
Okay.
What's that?
Basically, even the data.
That's right. That's right. So if you go to your question, all right, if I have a bunch of drives and I want to spread the data evenly across the drives, I could use hash partitioning. And that's so. All right. Any other? All right. This is more of a little behind here. We're having too much fun. So, okay. So, a little bit of one of the key things is they had some other things. This is a very nice feature, but just kind of gets people over the hump. Prior to Postgres 11, if I added a column and if the value was null, it would be fine. It would do it very quickly. But if the value was 1 or not null, it would actually go and have to visit each row and write the value, which, you know, that doesn't sound too bad, but, you know, if we have a 1 terabyte table, it takes a long time. And when you're altering a table, people don't realize, but you're taking a full table lock, all right? So you have a full table lock, and you have, you know, for 7 or 8 seconds can have a very big impact. But being able to have a non-default value, you know, just something that's very nice for DBAs and online production. A lot of vacuum that would actually skip the index scan. Anybody? This is a good. This is probably a whole other talk, but the way Postgres works, it has an MVCC architecture, where if I update a row, it actually inserts a new row. And so I have 2 copies of the row, and that's so that multiple transactions can see multiple versions of the row. But this leaves around what are called dead tuples. those tuples are periodically reclaimed in Postgres by vacuuming. Now, vacuuming can be expensive in the sense it takes a lot of, it can take CPU and disk, but it also has various implications on other processes that are running, and your tables can get bloated. All right. So there's all sorts of optimizations over the years for Postgres, but the new one is having a vacuum that'll actually skip the index scan and not vacuum the index and just the tables. Okay, another one. These are kind of some of the, what I would call some of the features you would have gotten in previous releases, but being able to validate a checksum on backups is important.
What's covering unique index?
I don't know. I did know, but I don't. I do not know. I think it's. I've given the talk forward, and I've talked about it, but this is about 30 years in the industry. I forgot. I remember. I forgot. I have forgotten.
You can look it up when we go home.
Yeah, there you go. All right. All right. So there's some other new features around parallelism. All right. Being create index can be 2 to 4 times faster with parallel hash joins, parallel no depends.
This parallelism is on the server level or
Is parallelism on the server level, or it's on the level? So it's parallelism that happens in the executor. So parallel workers work on different processes.
so you declare it or not?
You don't declare it. The planner it happens transparently to the planner. Good question.
So what do you do? You create any idle slave? Do you know what you're doing?
What it does is it creates background workers.
Right.
So the query is broken up into a series of worker processes, or it makes use of worker processes to execute the query. Whereas before it was all single threaded.
Right.
Whereas now you can have the query is actually taking place on multiple cores if you have them on the
Can you
machine.
set the degree of parallelism?
There's all sorts of tuning parameters for parallelism. Yeah. Okay. And you'll see this is where it's actually, you got to get to your question. It's actually saying in this case it's using 2 workers,
Right.
because there's 2 parallel threads that are participating in this query. All right. Just some other things that are. Get your book. Get your book. Whatever. All right. Sorry. Okay. So there are new roles, and these are roles. These are one thing that's very important to Postgres, and Postgres has a very nice and robust security model, particularly around roles. But there are various certain roles you want to assign to users. So if you want to have a user be able to execute programs on the server, there's a new role for that. Being able to read files, write files on the server, and it's just a matter of granting the role to a given user. Yeah, user dude. Yeah. So talking a little bit about things that made it into Postgres, I'll talk a little bit about things that did not make it into Postgres, which I do expect to show up in the next release of Postgres, or I'm hoping will show up in the next release of Postgres. The SQL merge syntax, anybody use that in any database? Okay. Okay. Yeah, so this is a feature that a lot of other databases have, and so this will be another thing that will blow away barriers to adoption. This is a very interesting thing. I no longer believe this is going to be in 12, but Postgres 12 will have something that I think is very important. It'll have the storage API, so you can have different storage engines for Postgres. That's been the big theme of Postgres, is having a storage interface. And that was something that I think really distinguished MySQL from Postgres, and that it had lots and lots of storage engines developed by third-party companies.
So MongoDB has that too.
Does it have that? Yeah. Okay. So it will have one of the storage engines that's being developed is something called Ziki, and I believe it will eliminate a lot of the need for. It's designed to eliminate the whole vacuum process I talked about earlier. It will actually have, as opposed to having new tuples, it will have undo logs to allow. So the whole vacuuming issues will go away. But that I think Ziki will follow into Postgres 13. There'll be much more partitioning enhancements. Quadrant has already contributed many more partitioning enhancements around performance to Postgres 12. Yeah.
What do you mean by enhancements?
Partitioning enhancement, what I mean by partitioning enhancements, a lot of them are around, just some, to give you an example, right now you can have, I might get this wrong, but you can have a partition table have a foreign key to a non-partition table, but you can't have a non-partition table have a foreign key to a partition table. So eliminating those kind of limitations, but also a lot around performance. So, making a query execute as fast on a partition table as it does on a non-partition table. And that's, to kind of eliminate some of the performance differences. Another one that I think will happen is, and this kind of goes to your example, if I'm doing something where I'm adding a new partition every minute, right? So not, every day is one thing, every year is one thing, but if I'm doing every minute, it'll take a full table lock. So I'm adding the partitioning. No other queries can get in when I'm adding and removing the permission. I'm adding or removing a partition. So that's the way it is in Postgres 11. I believe Postgres 12 will have a feature where you can remove a partition or add a partition, but still gain access to the table through update and read queries. So again, just kind of making some of these performance barriers.
Are these all edits that you make directly from Postgres, or are these things that are controlled through code outside?
No, these are things you'd contribute. These are things I'm anticipating will be in Postgres 12, which will be at the end of next year, and they'll all be going through the standard development process where people will contribute what they call patches, and then the committers will evaluate those patches, and if they meet the muster, we'll commit them.
I'm sorry, I probably asked the question correctly. When they are available, are these features that you normally, as a VBA, go into Postgres and administer, or could you access these features and control them through Python or something like that?
Oh, okay, very good question. Okay, so these features are all in many of these cases they're SQL, right? So any language you can execute SQL from, Python or whatever it may be, you can
R2.
make use of these features.
You're embedded in R2.
In R, yeah.
It's a database interface for
Yeah.
that.
Thank you.
You said that if you have a partition table, you can't have a phone key?
I can't remember which direction it is. If it's partition table, let me. I think. No, I had a slide on it. I had a slide on here. Okay, right. So you can have a foreign key in Postgres 11. You can have a foreign key to a non-partition table. The opposite's not true. And getting that fixed.
And what is transparent data encryption?
Transparent data is an excellent question. I no longer believe that will be part of 12. At one time when I wrote this presentation it would, but recent developments since then. The idea is that I don't have to encrypt the fields manually. It just happens, right? So the database is encrypted on disk. The application doesn't have to do anything to make it happen.
But you have higher CPU utilization.
Yes, you do. Nothing's for free, right?
No, because you have the same thing on Oracle.
Yeah.
And utilization is higher.
Yeah. But you get to comply and check all the security boxes for your regulations. So.
Some places you have to do that.
Yeah.
Just curious, what were some of those recent developments that?
I think people got diverted to other things. Nothing more than that. Other question?
Any GIS features that are
right? GIS.
Always a big
yeah.
part of,
that's actually one of the. I think GIS is probably one of the key reasons Postgres has gotten such adoption. There's an extension. So Postgres, one of its real core values is it's easy to write extensions, particularly for data types. And one of the most popular extensions is this extension called PostGIS. But that evolves independent of Postgres. So that's not part of the Postgres roadmap. It's part of another roadmap for that particular extension. So I think it's a very healthy extension, and I think but that's almost a whole other roadmap.
It's Postgres and Bank,
yeah.
The syntax is much simpler.
Mm-hmm. Is there any work planned for the encryption
I don't know of any. That doesn't mean there isn't. I just don't know of any. Look at this. Okay, so I was kind of talking a bit about some of the things that will happen in Postgres, could potentially happen in Postgres 12. I eliminated this one. This one I moved to 13, but I think the rest will potentially make it. So, summarizing Postgres 11, I'm taking you a little bit through the history and the development of Postgres, but have our 150 new features across all areas of the products. The significant features include massive improvements in partitioning, much more parallelism, gin compilation, and stored procedures. So if you were to give me the elevator pitch, this is what I would tell you about Postgres 11. All right, so that concludes my presentation for this evening. And you've been a wonderful audience, but I'll stick around and I'll take questions, and we can meet one-on-one or do whatever else you like. So thank you very much.
Tom Kincaid. Tom is here for one-on-one questions. Feel free to come up and ask. If you have not had your fill of food, I guess you still have some. So come on up. Thank you all for coming.